Transforming Mars into a second Earth has been pure science fiction for generations, a dream too impossible to take seriously. But what if I told you that's changing? Recent breakthroughs have shifted terraforming from impossible to merely very difficult. Today, we're diving into the science making researchers reconsider one of humanity's boldest ideas. Dr. Erica De Benedictis from Pioneer Labs recently authored a workshop summary that makes a striking claim. 30 years ago, terraforming Mars wasn't just hard, it was physically impossible. But three key technological revolutions have changed everything. First, launch costs. SpaceX's Starship could slash the cost of reaching Mars by 1,000. Second, synthetic biology has given us the tools to engineer life itself. And third, our climate modeling capabilities have advanced exponentially. The question is no longer, can we? But should we, and how? This is the story of how we might actually turn Mars green. The plan unfolds in three phases. Phase 1. Warming. Using engineered aerosols or greenhouse gases, scientists believe we could raise Mars's average temperature by tens of degrees within just a few decades. Why does this matter? Hidden beneath Mars's frozen surface lies enough water ice to create an ocean covering nearly 4 million square kilometers, larger than the Mediterranean Sea, at depths of 300 meters. A temperature increase of around 30 degrees Celsius could begin melting these frozen reserves. In billions of years, liquid water could flow on Mars's surface for the first time. But warming is just the beginning. Phase 2 brings life to Mars through synthetic biology. Researchers propose engineering extremophils, microbes that thrive in the harshest conditions imaginable. By combining extreme temperature tolerance, radiation resistance, and the ability to survive low atmospheric pressure, we could create organisms designed explicitly for Mars. These hardy pioneers could cover the planet with algae-like growth within decades. Through photosynthesis, they'd begin the slow transformation of Mars's atmosphere, converting carbon dioxide into oxygen. This would essentially fast-forward billions of years of evolution into a few generations. Phase 3 stretches across centuries, perhaps millennia. The goal: an oxygen-rich atmosphere thick enough to support complex life. It starts inside enormous domed habitats, 100 meters tall, where photosynthesis and water electrolysis generate breathable air. Beyond these protective structures, plant life gradually spreads, contributing oxygen to the broader atmosphere. This natural process alone would take 1,000 years. But eventually, the vision suggests humans could step outside those protective domes and breathe Mars's air directly. Walking on another planet without a spacesuit? Humanity's second home. But here's where it gets complicated. Critical unknowns remain. What lies beneath Mars's extensive ice sheets? How would dust storms behave in a warmer, wetter atmosphere? Are the materials needed for massive water electrolysis even available on Mars? Then come the ethical questions. If indigenous Martian life exists, even as microbes, our interventions could destroy it. Terraforming would end our opportunity to study Mars's pristine planetary history. These changes might not be reversible, yet there's an unexpected benefit. The technologies we develop for Mars could help Earth. Drought-resistant crops, sustainable closed-loop systems, renewable energy solutions, innovations from Mars research could benefit our home planet. The researchers aren't advocating we start tomorrow. Instead, they call for careful laboratory studies, detailed climate modeling, and small-scale experiments on future Mars missions. Before we consider transforming an entire world, we must understand what we're working with and risking. The conversation has evolved from could we to should we, and if so, how? And that shift, from science fiction to serious scientific inquiry, represents genuine progress. What do you think? Should we turn Mars green? Let me know in the comments below.